Welcome, everybody, and thanks for joining us today. My name is Dominic Taroli, and I'm responsible for 3D markets at Esri. With me today is Matthias Buehler, founder and CEO of Urban, and Simon Hegler, senior software engineer from the Esri R&D Center in Zurich. Glad to have both of you on the webinar, and welcome. Before we start, I would also like to say thank you to the people who made this webinar possible. That's Nancy and Eric from the Visual Effects Society, as well as Matthias and the whole team at Urban. Thank you very much for all your support. We couldn't have it done it without you. Now, what is on today's agenda? First, Simon will start with a short intro of CityEngine, which will lead directly to the brand new open source CityEngine plugin for Houdini called Palladio. Matt will then also show some concrete example and rule packages. And at the end, we have the summary, and we also should have some time for feedback and Q&A. Now, before we start, just quickly 3 housekeeping items to cover. If you have a question, please feel free to use the question window, type in your question, and then click send. Second, for your convenience, we set up a box folder with all the content and links from today's webinar. You can access this box folder at bit.ly/VES webinar_1808. This URL is case sensitive, so please write it quickly down or make a picture screenshot right now. Okay? And we will repeat that URL one more time at the end of the webinar. And last but not least, we will have a booth at SIGGRAPH next week in beautiful Vancouver. If you want to meet CityEngine's mastermind, Pascal Mueller, and myself for a personal meeting, please use the link bit.ly/SIGGRAPH2018. And please note that, again, this URL is case sensitive, and it's also in our box folder. But now let's get started with Simon about the brand new open source CityEngine plugin for Houdini called Palladio. Simon, I make you now a presenter, and the floor is yours.
Thank you, Dominic. Let me just quickly switch to my presentation. So I hope everybody can see this clip here running here. So thanks everybody for joining us. I would like to start our presentation about Palladio by quickly taking a look at a few showcases regarding to procedural worlds. I guess large complex environments, or specifically urban environments, are in high demand today and have been for the last couple of years, especially as all these dystopian movies and sci-fi movies are now produced, all these novels which are put on the screen. And so before we saw a clip from Blade Runner, this here is a clip or a scene from Independence Day. Both films employed procedural techniques extensively. Also CityEngine was used to populate the areas in the back or in between hero assets. And I guess one important aspect of all these environments, apart from their sheer size, is also the believability. I guess there's a bit of a similar effect as in character animation regarding the uncanny valley. I guess we are quite good as humans to see some implausible details of a scene, and so it's really important to have this believability in urban environments. And for example, here we see this big hero scene where CityEngine has been used to fill in the space between the hero assets, and this is simply not possible anymore with doing it manually, because especially if you need to iterate quickly, or if you need to be able to act on the direction or art direction changes. For example, if you need to move a street by a couple hundred meters, you need to move the buildings all manually. That doesn't cut it anymore. And so also in this Zootopia example here, procedural techniques and CityEngine has been used to design and lay out parts of the city. So I was talking about tools a lot, and so I guess as we are talking about another tool today, I will quickly kind of lay the ground for what tools there are for create procedural worlds in the VFX and gaming space. And so I guess on the general level, we have the traditional tools together with scripting languages. These are extremely widely used today to automate and in a procedural way manage scenes all across the studios. And if we drill a bit into the pipeline, on the upper end of the pipeline, we usually have the asset creation, the modeling departments. They use tools like Substance to create texture assets, like Houdini to create simulation assets, smoke, fire, destruction, water. We have CityEngine to create city layouts and building models, building assets. If we drill, or if we go down the pipeline, we arrive at the scene assembly or layout departments, where there are also tools which are in a sense procedural, as they use recipes to do vast layouts of assets like Clarice or Katana. Even in renders, I would dare say that there is a bit of proceduralism going on, in the sense of creating additional geometry elements at render time, or doing subdivision surfaces, or general DSOs, as they are called in the case of RenderMan. And even in compositing with Nuke, for example, you have a lot of proceduralism going on, as it also follows this kind of data graph recipe-based workflow. And last but not least, even in game engines, we see procedural workflows, because for big productions, also these tools provide the APIs and then scripting languages to kind of automate the setup of game and game levels and things like that. So for today's presentation about Palladio, we are focusing on Houdini and CityEngine, obviously. So Houdini is kind of a bit of like the bigger brother of CityEngine in terms of approach and proceduralism, in the sense that all your scene elements are dynamically connected. And so this kind of motivated us to try to combine these two tools and see what we can get out of integrating CityEngine into Houdini. So before I go on, I actually would like to hand it over to Matthias, and he will talk a bit about Houdini and CityEngine themselves.
Thank you, Simon. So let's dive into this. Okay, so here what we see is from YouTube. So this is the Houdini or one of the Houdini customer reels. So what we see is, of course, that Houdini has been used in a lot of different productions, but also in a lot of different, let's say, fields. So there's modeling going on, there's dynamics, particles, huge procedural environments, water effects, explosions, and so on and so on. But of course, also traditionally, architecture and cities have been created extensively using CityEngine, using Houdini. So on the other hand, we are talking about CityEngine at this point. So why would we use CityEngine, for example, if there are tools like Houdini? So CityEngine has become pretty much the most popular tool to actually design cities procedurally. There are a couple of very specific advantages, such as, for example, that it natively supports GIS data. So that means georeferenced building footprint, or GIS data in general, or satellite images, or elevation data. Additionally, we will talk about this a couple of times, is that CityEngine has this procedural scripting language called CGA that allows to procedurally generate models and geotypical looking buildings. So geotypical means that the buildings look like a specific region. intersection, for example. On the other hand, of course, you also have the ability to use or to actually derive statistics directly from these models. Now, a quick word about CGA. So CGA means computer-generated architecture, and the mechanism of how CityEngine per se actually works is quite simple in the end. So what you need is a so-called shape. So in the top left corner of the image, we see a couple of examples of shapes. So there's a single one. Whoops, there's a single one here. Then there's a series extracted from a city plan, and then there's a dynamic block taken from the dynamic city layout system of CityEngine per se. Now, to each of those shapes, you assign a CGA rule, and then you can so-called generate a building, as you see in the top, in the bottom half of the image. Now, the more code you're writing, or the further you go with the code, of course, you can generate more and more detailed architecture. But you can think about this also as some sort of, let's say, level of detail system. So you can stop the generation at any point to have either a simpler representation of a building or a very complex one. Here, what we are seeing is a building rule that was created by our friends at Houdini Lavinia, and as you see here, there's even the gazebos are parameterized or proceduralized. And if you have a rule like this available, it becomes very, very easy to generate lots and lots of variation of buildings of the same typology. Then if you combine, of course, multiple different types of rule sets, you can wind up with visualizations such as, for example, done at the city of Gothenburg in Sweden. So all their urban planning projects are basically visualized using CityEngine. Yeah, then so why would you use CityEngine at all? So we've covered the points a little bit. So Houdini is definitely it's a very special tool, or it is a special tool, but still it is a generalistic tool where you can do many, many different things. So you can do fluid simulations, you can do modeling, you can do character animation, and so on and so on. Yet when you are supposed to build a city, it becomes quite difficult because Houdini still is so generic. So you have to build up a system out of all the atomic nodes available in Houdini to create the building blocks, and in general the system that creates your city. And for pretty much all types of city, you will have to go pretty deep to actually derive or to create the system. On the other hand, you have CityEngine that is specialized in the creation of procedural architecture and city layouts. And the big advantage there, of course, you have CGA, which is a scripting language dedicated to the generation of architecture. So with this, I'm handing it back to Simon.
Thank you, Matt. So I would like to motivate Palladio a bit more by maybe looking at the traditional workflow with CityEngine. Let's assume we want to build an urban environment with CityEngine and Houdini. So usually you start with a bit of concept art, data sources, which you load into Houdini, and you work on terrains, on street networks, and then you write or author the architectural rules as explained by Matt, and your building models get created. And after that, all is exported into or the other packages, for example, Houdini. And then you can do further layouting, rendering, or even set up game levels or do virtual reality with that. So in detail, this looks like this for these two tools. Let's assume we use a data interchange format like Alembic. So in CityEngine, you do what I just mentioned, street layouts, buildings, and the model generation, and then you do an export. And on the Houdini side, you do an import. You maybe translate the properties so that they work with Houdini, and you do more Houdini things, as explained by Matt as well. And then you have to iterate, I guess, if you need to adjust your scene. So this can become quite tedious. What exactly do I mean with tedious? Let's look at a bit of some of the challenges. You have a lot of export-import overhead. I guess all of you who work a lot with geometry files know what that means. Export, reload, all these things. You have to deal with the attributes. And also, if you want to do level of detail, for example, if you have really, really heavy environments, you might want to switch between different level of details. So you need to have multiple exports and then combine those at import time. This gets complex. So as a goal, we would like to make this basically simpler with Palladio. And so one of the straightforward approaches in this niche here, we kind of thought we should defer the CityEngine model generation into Houdini. So there's no magic here. This is quite logic. And this is the point I would like to introduce Palladio. So Palladio is a CityEngine plugin for Houdini. It's based on the CityEngine SDK, actually also, of course, on the Houdini APIs. It provides Houdini with few custom operators, and it's all open sourced on GitHub. I will tell you the details later where to get the sources. At this point, I should probably note that Palladio is not an official product, therefore from Urban nor from Esri. It's a purely open source project. From a bird's eye perspective, Palladio works as follows. In CityEngine, you author your rules for the procedural buildings. You export those in rule packages. A rule package is basically a zip file with the rules and all the assets which are needed to create the building. Then in Houdini, you set up parcels or building footprints. Those are fed into the Palladio operators, and out after cooking, you get the Houdini geometry, or I should say the building models as Houdini geometry, and you can continue working with them. What motivated us to create Palladio? So first, this was actually a technical experiment. We were trying to validate the CityEngine APIs and how they were designed. And we quickly noticed that there is some new workflows which this enables inside Houdini, and we can also actually achieve our goals to reduce all this export-import of files on the building level. So now it's time to finally look at Palladio itself, and for this I hand it over to Matt again, who will show us some nice stuff.
Thank you, Simon. So yeah, let's dive into two examples. So if you are in CityEngine and you have created a rule package, or you have created a rule, sorry. So the rule is basically just a text file, .cga. Now, if you right-click on that one, you can say share as, and then you get the dialog. And here you can click on save package to file, which will, if you click share, generate the rule package, which then is a standalone file. So let's have a look at a very simple example here on a building. So that's a very simple rule that generates a building representation on a rectangular building footprint. That is the so-called shape in CityEngine terminology. You see also, once the rule is assigned, you see all the attributes which are exposed in the code. with their default evaluated values in the CityEngine inspector. So that's this little UI element here on the left. Now, if you go over to Houdini and do exactly the same thing, you take a grid from which you are generating a rectangular building footprint, which is basically just a primitive. And then you have the two nodes, which Simon will talk about a little bit more later on, which is first of all the assign node and the generate node. So the assign node is the node that actually where you point to the rule package that you have just generated. Then if you cook that network, what you will get is obviously the exact same building. Moving on, now we start to see the advantage of having these two nodes. So the PLD assign node points to the rule file and then evaluates the default attribution as we have seen it in CityEngine, and those are then piped basically down into the generate node with those values. Now this is the sweet spot, the sweet spot where you can actually intervene and create an attribute override. So in this case, I just went in and created an attribute create node with the name number of floors or number floors. So that's exactly the same name as defined in the rule package. And I said, well, you should have a value of 10. So if you cook that network now, the building will obviously create or will be created with 10 floors instead. Second example. Okay, so here we go. So in this second example, we see a little video of an animation that looks a little bit like a graveyard of 80s computers. And we have created this animation directly, or also using Palladio, created this animation for the release of Palladio just very short ago. We see here that there are a couple of elements that make up the scene. So we have some streets with simplistic cars placed on them. We have some open spaces, and then we have buildings, it seems, and the orange spaghetti that are just basically like a fishnet wrapped around all of the buildings. So let's look at the elements again. In CityEngine, what we created was, first of all, a rule package which creates like the block layout. So first of all, it creates first and secondary streets, which then leaves us with some, let's say, bigger parcels or blocks, city blocks. The second rule package actually processes a city block, so it can generate like layouts for gardens or for where the buildings are placed, and so on and so on. And then the third rule package generates two types of buildings. The left one here is an industrial building, while the right one, the lighter one here, is a residential building. Moving on. In Houdini, what we are creating again is a big area. So that's about, I think, 8 by 8 kilometers or something like 5.5 miles square, just as a simple primitive, which we are using in this example as the base for our city model. Very simple. So first rule package is assigned, and it does what it's supposed to do. It cuts the big streets, the small streets, and leaves some space open for public squares and for buildings. And then and that is actually the beautiful thing that is not per se or not directly possible using just CityEngine by itself. But what you can actually do is take the results from one generation phase using Palladio and pump it directly into another Palladio node. So that means you can basically daisy chain multiple phases of generation. So in this case, the open spaces are taken and pumped directly into a rule which creates the further layouts to subdivide those blocks. Moving on, next step with the building positions, the buildings rule package generates the buildings, and then in the last step, for each of those buildings, we are creating a convex hull using Houdini's native tools, and using a polywire sub, we create the spaghetti going around those around that convex hull. Combining everything together, all the merged geometries and having the materials applied in the viewport, the scene looks like this. And then, so let's go ahead and have another quick look again at this animation. And this is how this scene was created. So I'm giving it back to Simon.
Okay, thanks, Matt. So let's take a bit of a closer look in these two nodes which Matt just used. So we start again with the Houdini geometry, and then the first node. So we call that PLD assign. PLD stands for Palladio, obviously. This is basically the node who assigns the default values extracted from the rule package to the primitive polygons. You can also group several polygons to form one building footprint, for example, if you have multiple wings in a building. Once you have these attributed polygons, you can then do what Matt demonstrated and modify and override its attributes to drive the whole look of your city. Especially interesting is to use paint effects or simulation outputs to modify your buildings. The main node is called PLD generate, which actually evaluates the rules, creates the geometry, and additionally emits additional attributes. Those could be CGI reports. So if you're interested in, for example, the gross floor area of a building, or you can also assign or work with material attributes and assign them to the shaders directly. And in the end, obviously, you can do more Houdini things with the geometry. So now let's look at a more complex example, and I hand it back to Matt again.
Thank you, Simon. Okay, so for a good example, I did a little bit search online to find something that actually shows pretty clearly or some advantages of using both CityEngine and Houdini at the same time. And I found this reference photo. So this is a photo, by the way, it's not rendered, of this really nice temple in Cambodia called Angkor Thom. So a lot of you may know this from actually having been there. Yeah, so I have studied a lot of reference images of this site, and I isolated a couple of elements, of architectural elements that basically make up the main structure of this of the architecture of this photograph. So, for example, what we have is walls with some sort of doorways. We have fields, or let's say areas with broken columns. We have a floor. We have arrays, or let's say lines with intact columns that actually have some beams missing on top. We have some stone arrays. We have stairs and the elements like this. So I went ahead, and for each of those elements that I just mentioned, I created a rule package. Now, some of them, or actually just two of them, have also a little bit of deco elements or deco 3D assets, like this face here, or it's not really visible here, but at the vertical wall of the floor, basically, there are some cylindrical elements elements protruding. So going to Houdini, what I did is I created a just a big grid at the beginning that is basically showing the extent of the whole set or digital set that I would like to generate for this, let's say, shot, quote unquote. Going on, I selected for one of the rule packages, which will be the column array. I created just manually a selection of polygons or of primitives where I wanted specifically these columns to be. Next step, assigning the rule package to that selection using the assign and the generate node, and the resulting geometry that is produced looks something like this. Still a little bit clean for my taste, but let's move on. So using that output of Palladio, I now continue using the native Houdini tools to create, for example, something like this. Digital asset that takes the output of Palladio and converts into something that looks a little bit more convincingly like a stone column. So there's this digital asset contains a network that uses like things like VOP and or VDBs and mountain SOPs and so on to create this representation that looks more like a realistic weathered stone. Now this we are taking as another input for the procedural vines or dry vines, which I just wanted to add on top as a, let's say, deco element or to make the geometries look a little bit more rich. So that's also something that is done quite easily in using Houdini. So again, let's just have a look at these steps in the rendering. So first step is just the clean output out of Palladio with the architectural columns. Then next step, using Houdini's native tools to weather the geometries and add some geometric detail. Then the third point, to actually add some of the dry vines. Now assigned to all of the elements, the scene looks like this in the viewport. So we have all the different columns, the stone piles, a little bit of grass and so on, that make up this finalized scene. Just a quick rendering or two here. So the first one a little bit from further away, and the one that is more close that actually shows all the little detail added on top of those procedurally generated topology or geometries. Now, obviously, you start to see the advantage of using the combination between procedural or the highly specialized procedural system that can generate pretty much arbitrary types of architecture using CGA or rule packages, but then also processing those geometries using the native Houdini tools on where its absolute strengths are and where CityEngine is limited. So it's like combining best of the two worlds. And basically none of these columns that you see here have been modeled or sculpted. It's really, and every single column is absolutely unique in its geometry. So therefore, it almost becomes like a layout that the layout artist becomes somehow the modeler. So it's really, really fascinating. But yeah, let's go back to Simon.
Thanks for this example, Matt. So I would like to summarize and conclude our presentation of Palladio by quickly looking at pros and cons of what we have seen. So some of the pros and advantages are obviously that we could reduce some of the overhead. we can directly work with Houdini attributes and deriving those rules from CityEngine. But the most fascinating part is actually that you have new possibilities which you do not have in CityEngine standalone. And this is mainly that you can chain multiple rule packages and kind of combine, kind of nicely modularize your rules and then combine those in Houdini. There's a bit of a small print, as always. You have to export those rule packages beforehand. And as the CityEngine SDK is currently only working on buildings, you cannot easily get the whole street networks and terrain layers and stuff inside Palladio. So this would remain the classic export-import workflow for the moment. And also, as Houdini is not really working with GIS coordinate systems, you have to first un-georeference your CityEngine data before you work with it in Houdini. And in terms of requirement, you need a CityEngine license to run Palladio, and of course you need a Houdini installation. But the nice thing is that also the personal learning edition Houdini Apprentice works for Palladio. Before I conclude, I would like to just look at two major AI items we have on our roadmap. The first one is that we would like to make it possible to reference live Houdini assets from within the CityEngine architectural rules. So that could enable nice workflows where you could reduce the export-import cycle even more. And the most interesting step for us is actually to add support for Houdini digital assets. So you could wrap up Palladio and all the surrounding Houdini operators in a nice standalone HDA and make it work, for example, in Houdini Engine. So we did a little experiment you see here on the bottom. That's actually a Palladio / CityEngine rule working live in Unreal, the Unreal Engine. And you have the same user interface elements. Basically, you see the attributes and you can modify those interactively. With this, I would like to invite you to give it a try. So the source code and binaries are available on github.com/esri/Palladio. Providing the binaries is currently a best effort basis because we cannot really build binaries for all the different Houdini versions there are. But we have more or less the latest one available right now. And I would also like to invite you to join us on Slack if you have any feedback or question or would like to tinker with it yourself. The team is called Palladio-Houdini-ce.slack.com. And with this, I'm at the end and would like to give it back to Dominic.
Thank you very much, Simon and Matt. And very cool. And this will definitely bring CityEngine and Houdini users even closer together. Therefore, allow me to invite you to test drive CityEngine. And you can download the free 30-day CityEngine trial at esri.com/CityEngine and on esri.com/visual effects, VFX. You will find predefined buttons for artists, projects, studios, and even students. And again, for your convenience, we set up that box folder with all the content and links from today's webinar, for example, that CityEngine trial link. And you can access this box folder at bit.ly/VES webinar_1808. And if you are going to SIGGRAPH next week and you want to meet us, then please use the link bit.ly/SIGGRAPH2018 to reserve your personal meeting slot. But now let's get started with the Q&A. And if you have a question, please use the question window. And you're doing that by typing in your question and then click send. So let's get started with the first question, and it's coming from UJ. And the question is, will this be available online?
I guess online is referring to kind of a web app, I guess.
It's only, will this be available online? And I mean, it's a plugin, so it's like it's available on GitHub, and then you have to download it. And I think that will be the answer.
Yeah. So yes, it's downloadable from GitHub/online, and you will need to install it in your Houdini installation and restart, and you're good.
Then you triggered some interest in Unity. So JD is asking, would you please provide any guidance on the best way to use Houdini with Unity?
Yeah, so there are obviously different ways so far of exporting geometries to Unity using like standard things like FBX and so on. So that's the common way. But as in the latest example of or on the element actually, or the entry on the roadmap that Simon just showed before, is we are hoping that we will be able to solve the technical issues of using HDAs in or with Palladio. So that means that we could actually piggyback on top of Houdini engine, and this would actually also work in Unity. So as you guys may know, Houdini engine actually works in Maya, Max, Cinema 4D, Unreal, and Unity. So I guess if we have solved it for Houdini engine in general, it should also work in Unity.
Thank you. Next question is from Coscu. And he's asking, can we export curves for roads and sidewalks for further modification of the instanted assets, or extract curves from the CityEngine rules?
What you could do is just generate the street network in CityEngine and port that either with or without attribution, depends a little bit on the workflow, via, for example, Alembic or an OBJ, and then rip it apart there and use it as shapes. So I would say, or I would recommend Alembic. But it depends a little bit on the workflow. But so in general, yes, or let's say you cannot bring the curves or the dynamic city layouts, but you can bring the shapes over to process with the rule packages.
Okay. Now, thanks for all the questions. I would say we're taking two more. One is, for which platforms is Palladio available?
So we currently provide binaries for Windows and Linux, and there's some experiments going on for Mac, but that's not really ready yet.
Okay. And last one is from Jose Naranjo, and he is asking, is it possible to define custom attributes in CityEngine that we could use in Houdini and in engine integration?
Yeah, that's definitely possible. That's what we call user attributes or custom attributes in CGA. So basically all the attributes you define in the rules are optionally available on the created geometry then back in Houdini, and then you can actually act on those attributes and do any Houdini thing you like.
Okay. I think that's all for now. If we could not answer your question during the webinar, we will come back to you directly via email or phone. And let me now conclude the webinar by saying thanks to Matt and Simon for a great webinar and a lot of insights with Palladio and CityEngine. Furthermore, I would also like to thank again Nancy and Eric from the Visual Effects Society to make this happen. And also thank you for joining us today. And we hope to see you all next week at SIGGRAPH in beautiful Vancouver. And with that, I would like to say goodbye and auf Wiedersehen.
Bye-bye.
Bye, guys. Bye-bye.